All right, so we're ready for the next short video. This time I want to talk a little bit about displaying the data that we spoke of in the first video and different sampling methods, ways in which we go about acquiring data, which are the best ways to acquire the data, what are some other ways, and which are the best way to collect data. So in the last video, we talked about categorical data versus quantitative data. Most of this class will be dealing with numerical data or quantitative. When we get into future chapters, most of our analysis will deal with numerical data. Right now, we also are looking at categorical data. Categorical data can be displayed in different ways. In a pie chart, I think we're all somewhat familiar with a pie chart where you just split up the pizza pie or whatever you want to think about it as into sections, and you put however many of the observations of whatever it is you're looking at falling into each of, in this case, 3 categories. Now, when you use a pie chart, you have to have the total add up to 100% of the circle of the pie, right? So sometimes you'll have data that don't add up to 100% or maybe more than 100% if somebody can answer 2 different categories as an answer, but a pie chart must add up to 100% of the data. And pie charts are only going to be used again for categorical data. We can also use a bar chart to express categorical data. If we have 4 different categories here and a certain number of observations on the vertical scale, we can, hopefully you can see that clearly, 4 different categories, number of observations in each category. So just the height of the bar is telling us how many observations fall in each one of these categories, right? This looks like about 10. This might be 6 or so. This could be 15, 14. It's not exact scale here. And this is down there around 3, 4, something like that. Okay, so a bar chart is for discrete data. Also, we can use this for a numerical data if it's discrete, right? If we had the example we used earlier was number of children that women have in a certain place. You know, we could have 0 children, 1 child, 2 children, 3 children. If it's discrete data, we can use a bar chart. If the data is continuous, and remember we talked about the difference between discrete data and continuous data. Continuous data cannot be expressed in a bar chart because there's values in between, right, that are left out in a bar chart. So only discrete data here, or categorical data. Here in a histogram, we can use a histogram for numerical data because there's no gaps between the bars here. So we create this in such a way that even if we have things measured down to a fraction of an inch, we make it so that our value is going to either fall in one or the other category. If we had it down to the ½ inch, we would make this a ¼ inch boundary here so that no matter which side of that measurement, it would fall either in A or B. So there's nothing in between here. This can be used for continuous data, a histogram, no gaps between the bars. Okay, a Pareto chart is basically just a bar chart or a histogram with descending order of categories, right? So if you're asked to create a Pareto chart, what you're going to do is just rearrange the categories in a way such that the categories go from left to right with the most values to the left and then descending down to the right. Okay, so that's a Pareto chart. So know your different kinds of charts, pie charts for categorical data. Bar charts can be used for categorical data or discrete numerical data, continuous data. We will deal much more with continuous data in the future, and we will use something called a probability density, but that's a future chapter. For now, we can just see a histogram, which is basically a bar chart with no gaps between the bars so that we can fit every individual measurement into one of those categories. And a Pareto chart is just a bar chart with descending order. All right, so we also want to talk about sampling methods. So sampling methods here, different ways to collect the sample. We want to know the best way to collect the sample. The best way is something called a simple random sample. And again, as we get into later chapters here, we're going to use simple random samples 99% of the time. But for now, we want to know the others as well. A simple random sample, by definition, is every member of the group or population that we're taking the sample from has an equal chance of being selected for the sample. Okay? You have to think about that definition. So if we have, if 100 people is our group, our population, we want and we're taking a sample of size 10, say, we need every possible group of 10 people out of that 100 to have the same chance, the same probability to be selected for the sample. Okay, that's a simple random sample. And when you're told that the sample you took is a simple random sample, that means that we have mixed up the population in a way that every group of those n individuals, the size of the sample, has the same chance of being selected for the sample. Okay, that's the best way. That's the way we want to do it. Think of picking numbers out of a hat, right? Where there's no bias, there's no my thoughts going into who gets picked. It's completely random, simple random sample. Okay, so other types of samples. Stratified sample is a way of breaking down a population into layers. Think of stratified rock. We break it into layers, and then we take a simple random sample from each of those layers. Okay, so think of if we wanted to take a sample of all college students in the state of New Mexico. So there's, I don't know how many schools, colleges in New Mexico, maybe 20, let's say. So if we wanted to take a sample of all college students in New Mexico, we could break that down into the 20 individual schools and then take a simple random sample of however many from each of those schools. That's a stratified sample. Now that is often confused with a cluster sample. Okay, so once again, stratified, we break into groups, take a simple random sample from each of those groups. The difference with a cluster sample, the first step is the same. We break it into groups, but now we take a simple random sample of the groups and include everything in that group. Okay, so very subtle difference between stratified and cluster. Using the same example, if we want a sample of college students in New Mexico and we take a cluster sample, we're still going to break it down into we said 20 schools in New Mexico. But now we're going to take a sample of the schools. So we're going to choose, say, 5 of those schools and include all the students in each one of those 5 schools. Okay, so stratified and cluster, similar but different. A convenient sample is just the easiest way to get your sample. Let's say I wanted a sample of ENMU students, and I just take the people in my class because, you're here, it's easy. It's not a very good way to collect data. You're probably not getting a representative sample, right? Representative, I believe we talked about before. We want our sample to represent the population that we're interested in. So a convenient sample has a smaller chance of being representative of the entire population. A systematic sample is just if I stood in the hallway and I took every third person that walked by. That's a systematic sample. It's not a simple random sample because if I take the third person, then the fourth and fifth person have no chance of being in my sample. Therefore, it's not a simple random sample. We call that a systematic sample. And there's always going to be sampling errors. Okay, no matter how we take the sample, even if we take it the best way, there's always going to be errors. If I take a simple random sample of 500 people and you take a simple random sample of 500 people and we measure something, say heights or weights or something like that, we're going to get different results. Okay, and that's what sampling errors mean. There's always going to be some variation among the samples, and we just have to accept that. That's why we try to pick the sample in the best possible way, and then we analyze it as we can, and we'll learn more about that as we go along. All right, so again, trying to keep these short. I will see you soon.